So page 12 of chapter 16, Euler's complex numbers, Math HL. Number 9a, use complex number methods to deduce that cosine 3 theta equals cosine cubed theta minus 3 cosine theta. And in the second part, we're going to prove sine theta equals 3 sine theta minus 4 sine cubed theta. So basically, let's focus on this here. If we're going to use complex number methods, we are going to have a cosine part and a sine part, and you notice that they want us to do work with 3 theta in both cases. So what if we said, okay, I am going to have a complex number that is cosine 3 theta plus I sine theta, sine 3 theta. That is equal to cis 3 theta, right? So cis 3 theta can be rewritten with the de Moivre's theorem as cis theta cubed. And cis theta cubed can be written as cosine theta plus I sine theta cubed. And if we expand that with binomial expansion, we'll get cosine cubed theta cosine cubed theta. We get cosine squared theta times I sine theta. We get cosine theta times negative sine squared theta, because the I squared is -1. And then we get negative I sine cubed theta. If we take the real parts, which is this part and this part, and we take the imaginary parts, which is this part and this part, and we separate them, we'll get cosine cubed theta minus 3 cosine theta sine squared theta. And for the imaginary part, we'll get plus I times 3 cosine squared theta sine theta minus sine cubed theta. Now, how about if we use Pythagorean Theorem? Sine squared plus cosine squared equals 1, and then we'll replace sine squared equals 1 minus cosine squared. So we'll put cosine of cubed theta minus 3 cosine theta, and instead of sine squared theta, we're going to put 1 minus cosine squared theta. And then for for the imaginary part, we're going to do the same, except for we're going to replace cosine squared with 1 minus sine squared. Okay, and then let's combine, let's expand and then combine like terms. So we got minus 3 cosine theta minus or plus 3 cosine cubed theta, and this is cosine cubed theta, plus I times 3 sine theta minus 3 sine cubed theta minus sine cubed theta. And this is going to be cosine cubed theta plus 3 cosine cubed theta is 4 cosine cubed theta minus 3 cosine theta. And the imaginary part is going to be the cubes added together again. So it's going to be 3 sine theta minus 4 sine cubed theta. So we can see that the real part, which is cosine 3 theta, is equal to this real part, which is 4 cosine cubed theta minus 3 cosine theta. And the imaginary part, sine 3 theta, is equal to 3 sine theta minus 4 sine cubed theta. So we have shown both this and we have shown this. Okay, so let's shrink this down a little bit, make some space. And then we'll work on tangent 3 theta. Hence, find tangent 3 theta in terms of tangent theta only. So tangent 3 theta is equal to sine 3 theta divided by cosine 3 theta. So we could put that as 3 sine theta minus 4 sine cubed theta divided by 4 cosine cubed theta minus 3 cosine theta. So first we're going to factor out sine from the top and cosine from the bottom. So we'll factor out sine theta, and we'll have 3 minus 4 sine squared theta. And we factor out cosine theta from the bottom, so we'll have 4 cosine squared theta minus 3. And then we're going to use sine squared plus cosine squared equals 1 to replace the 1's here and here. By doing that, we're going to have everything here with sine squareds in it and cosine squareds in it. And then we just divide everything by cosine. And then all these sine squareds will become sine squared divided by cosine squared, which is tangent squared. And all the cosines will become cosine squared divided by cosine squared, which is just going to be 1. So that's how we're going to make everything into either a number or a tangent. So instead of negative 3, we're going to put negative 3 times sine squared plus cosine squared. And instead of positive 3, we're going to put 3 times sine squared plus cosine squared. So here I'm going to rewrite this one. It's going to be sine theta, 3 sine squared theta, plus 3 cosine squared theta. That's equal to 3, right? Minus 4 sine squared theta. And the bottom is going to be cosine theta. And it's going to be 4 cosine squared theta minus 3 sine squared theta minus 3 cosine squared theta. And the sine divided by cosine here becomes tangent of theta in the numerator. And then if we divide everything on the top by cosine squared theta, and we divide everything on the bottom by cosine squared theta, then we're going to get 3 tangent squared. Oh, by the way, we can combine 3 sine squared theta with minus 4 sine squared theta, and that'll give us negative 1 sine squared theta, right? So it'd be negative sine squared theta. And then plus 3 cosine squared theta divided by cosine squared theta. We haven't done that yet. On the bottom, we're going to take our 4 cosine squared theta and subtract 3 cosine squared theta. So we get cosine squared theta minus 3 sine squared theta divided by cosine squared theta. And so we'll have tangent of theta. Negative sine squared theta divided by cosine squared theta is equal to negative tangent squared theta. 3 cosine squared theta divided by cosine squared theta is 3. In the denominator, we have cosine squared theta divided by cosine squared theta, that's 1. Minus 3 sine squared theta divided by cosine squared theta, that's minus 3 tangent squared theta. And then we can distribute. So we'll get 3 minus tangent, 3 times tangent theta minus tangent cubed theta on top, and on the bottom we'll have 1 minus 3 tangent cubed theta. So C, hence solve these equations, and 4x cubed minus 3x, doesn't that look a lot like this real part for that? So if x was cosine theta, then it would be a match, wouldn't it? So let's do that. Let's say that x equals cosine theta. And if we do that, then instead of 4x cubed minus 3x equals negative 1 over square root of 2, we'll have 4 cosine cubed theta minus 3 cosine theta is equal to negative 1 over square root of 2. And we also know that cosine cubed theta, or 4 cosine cubed theta, there's no parentheses here. 4 cosine cubed theta minus 3 cosine theta is equal to cosine 3 theta, as we discovered. So basically we got cosine 3 theta equals negative 1 over square root of 2. So what angle gives us a cosine value of negative 1 over square root of 2? So that could be a 45-degree triangle in that direction, or it could be a 45-degree triangle in that direction. So basically we know that 3 theta is going to be equal to 3/4 pi or negative 3/4 pi. Or any multiple of 2 pi based on that. So we could say plus 2 pi k or plus 2 pi k, where k is any integer. Now theta would be equal to all that divided by 3, so it would be pi over 4 plus 2/3 pi k, or negative pi over 4 plus 2/3 pi k. The part 2. So remember this last thing we derived. Just one correction. Did you notice that I accidentally put a 3 there? This is supposed to be tangent squared theta. Okay. And I can make this look like this. And the way I'm going to do that is I'm going to make x equals tangent of theta. If I make x equals tangent of theta, then this and this is going to be equal to that. And this and this is going to be kind of equal to that. Okay, so let me show you how that's going to work. By the way, don't get the wrong idea. I'm not like getting these out of my hat here. I had to look at the solutions on this because I had no idea what they wanted. But once you see the first line of it, it's not so hard, right? So if we know that x equals tangent of theta, then we could write this as tangent cubed theta minus 3 square root of x tangent squared theta minus 3 tangent theta plus square root of 3 equals 0. And first thing we're going to do, we're going to take the orange terms, this one and this one, and we're going to subtract it over to the right side. We're going to be left with 3 square root of x tangent, oh, it's not square root of x, it's going to be square root of, sorry about that. This is square root of 3, right? 3 square root of 3 tangent squared theta plus square root of 3 is equal to, and we're going to subtract the two orange terms to the other side, so we'll get 3 tangent of theta minus tangent cubed theta, and we got exactly the top of this, right? Then we're going to factor out square root of 3, and we'll get 1 minus 3 tangent cubed squared theta on the left side. And then we could divide both sides by 1 minus 3 tangent squared theta. 1 minus 3 tangent squared theta. So square root of 3 is equal to 3 tangent theta minus tangent cubed theta divided by 1 minus 3 tangent squared theta. And 3 tangent theta minus tangent cubed theta divided by 1 minus 3 tangent squared theta is equal to what? It's equal to tangent 3 theta. So this is equal to tangent 3 theta. So tangent 3 theta is equal to the square root of 3. So what are the angles which give you a tangent of square root of 3? So that would be 30, 60, 90 triangle in this direction, 30, 60, 90 triangle in this direction. So 3 theta is equal to pi over 3 plus 2 pi k, or equal to pi 4/3 pi plus 2 pi k. And then theta would be equal to pi over 9 plus 2/3 pi k, or 4/9 pi plus 2/3 pi k, where k is an integer. Okay, here we're going to do a similar problem for 11, except now it's 4 theta. So we're going to do a similar approach. We're going to take cosine 4 theta, and we are going to find an analog, which would be cis 4 theta. And we'll try to take the real part of that and see if that's equal to this, okay? Because cis 4 theta is actually equal to, cis 4 theta is equal to cosine 4 theta plus I sine 4 theta, right? So if we find another expression for 4 theta, we could just take the real part of that and it would equal for cosine 4 theta, right? So what if we use de Moivre's, and we know that cis 4 theta is actually equal to cis theta to the 4th, right? So we could, let's see, let's expand this with binomial expansion. So that would be 1, 4, 6, 4, 1. And it would be, let's see, cosine theta plus I sine theta to the 4th, right? So this would be cosine to the fourth theta, and the sine theta exponent would be 0, so nothing here. Let me just make that exponent for it. And this would be for cosine cubed theta, sine theta, I. And this would be 6 cosine squared theta, sine squared theta, and there would be I squared, which would be minus 1. We don't need that. We'll just put the minus. And then we have a cosine theta, sine cubed theta, which would be a minus 1 times I, which would be a negative I. And then finally, there would be a cosine, the cosine would be to the 0 power, and that would be sine to the fourth theta, and that would be negative I times I, which would just be positive 1. So that is my expansion. Then I divide it in the real and the imaginary parts. And so the real parts is what I'm concerned with, because I want to know what cosine 4 theta is, which is the real part. So it would be this, this, and this. So it would be cosine to the fourth theta minus 6 cosine squared theta sine squared theta plus sine to the fourth theta. And I want to find everything in terms of cosine theta. So what I could do is I could replace the sine squareds. Remember that sine squared plus cosine squared equals 1. So I could take my cosine or sine squareds and I could replace them with sine squared equals 1 minus cosine squared, right? So over here I have cosine to the fourth theta. Whenever I do that, it doesn't look like an exponent, does it? So minus 6 cosine squared theta times 1 minus cosine squared theta. Hear that? The garbage truck? It's really loud. 1 minus cosine squared theta squared. So let's expand this. Cosine to the fourth theta minus 6 cosine squared theta plus 6 cosine to the fourth theta plus 1 minus cosine, oops, I didn't do FOIL. So this needs to do FOIL. Now the trash truck's going to be really loud because it's going up the hill. 1 minus 2 cosine squared theta plus cosine to the fourth theta. The window's closed, so it's not that bad. Okay, so here I have 2 cosine to the fourth theta, so I could write 2 cosine to the fourth thetas. And I have minus 6 cosine squared theta and minus 2 cosine squared theta. Oh, I forgot about this 6 cosine to the fourth theta. So that would be 8 cosine to the fourth theta. 8. And then minus 6 cosine squared theta minus 2 cosine squared theta, which would be minus 8 cosine squared theta plus 1.